Good morning.
Good morning, ma'am. Very good morning.
ma'am. Good morning.
Good morning. I hope you people have received the material,
Yes,
Yes,
ma'am.
ma'am.
Yes.
isn't it? So just
Thank you,
go
ma'am.
through
Thank
it.
you so much.
Thank you. And I've shared one PPT which is having the basics of statistics also and how to download tool pack also. Okay, so just go through it. And if you have any doubts here, if you want to know more, you can contact me. My details are also given over here. I've shared my personal website link also. I hope I'm audible.
Yes,
Hello?
ma'am. Ma'am, you are audible.
Yes, ma'am. Yes, ma'am.
Okay. Like I'm getting some comments like I'm not audible. That's why I've
Ma'am,
just.
in between your voice is breaking.
Okay, fine, fine.
Yeah, participants will be starting the session at 10:30 sharp. I think there is some connectivity issue, thus we cannot hear Shiny ma'am. We are waiting for more participants to join in, and in 2 minutes we'll be starting.
Good morning, Shani ma'am.
So I guess there is
Yes,
some
yes,
network
Ajit.
connectivity issue from Shiny ma'am. Yeah, ma'am is available now.
Ma'am, good morning. How are you?
Good morning, Ajit. कैसे हो?
I'm good, ma'am. How are you?
I'm also good, thank you. I hope you are enjoying the FDP.
Yes, ma'am, obviously.
Yeah. Good morning, sir.
Yeah, good morning, ma'am. Good morning.
Ji, good.
Yes, good morning, Saurabh sir.
Yeah, good morning, ma'am.
Sir, we will be starting the session in a minute.
Yeah, let some more
So
people join.
that will be okay, right?
Yeah,
Right. So I'll quickly post a message to the participants, and in a minute we'll start. So the numbers are increasing. We will start. Yeah. So your screen is visible.
Right, ma'am. We'll start, I think, another
Yeah.
2 minutes.
A very good morning to everyone once again. I, Dr. Rucha Lohi. Yeah. Yes, sir.
I think we'll start in another 2 minutes, ma'am. Let people join.
Saurabh, sir, you're audible.
Let people join. That is what I'm saying.
Right, right. Okay, so I have already posted a message for the participants and they are joining. So shall we wait for a while?
Yeah, let us wait for 2 minutes. Let them join so that it is beneficial for everybody.
Right, right. Okay, okay. No problem, sir. Fine, fine. No problem, sir. Yes, participants, we are waiting for other participants to join in, and thus the session has not yet begun. I could see in the chat, therefore the announcement. Saurabh sir, shall we start?
Yeah, ma'am. I think we should start now.
Yeah. Once again, a very good morning to all the participants and our expert resource, Sir Saurabh Agrawal. I would like to welcome you all once again on behalf of Datta Meghe Institute of Management Studies to day 4 of AICT Atal FDT on quantification of human resource with HR analytics. Today we'll be continuing the sessions we left yesterday. So we again have our expert speaker, Dr. Saurabh Agrawal, sir. Sir, I request you to take over, Shin.
Okay. Good morning, Shiny ma'am. Good morning, Ruja ma'am, and good morning, a very good morning to all the participants.
Good morning, sir.
We'll begin with the whatever we were discussing yesterday, and whatever feedback I could get from all of you. I have taken a data set which is on a Likert scale, because most of you, I think, are working on such kind of a scale. So I've taken a data set which is on a Likert scale, and trying to do what best is possible or what is actually done on a data which is collected on a Likert scale. I'll go through this analysis, right? It is a very fundamental analysis which is generally done as a pilot study once we have collected the data on the Likert scale, right? So the data set which I'm sharing with all of you, it's a data set on which the research was actually done. The objective was how inquisitive the research scholars are in using SPSS for analyzing their data. And to do this, we collected a questionnaire on 23 questions. I'll just read out a few questions. And the Likert scale was from strongly agree to strongly disagree. It was a 5-point Likert scale, right? So I'm just trying to tell you what actually is done on a data which is collected on a Likert scale, right? So I'll just read out a few questions which were related to this objective. Statistics makes me cry. I don't understand statistics. All computers hate me. I have little experience of computers. I did badly at mathematics at school. Computers are out to get me. People try. SPSS always crashes when I try to use it, and so we have questions related to SPSS. We have questions related to computers. We have questions related to statistics. We have questions related to mathematics, and so on, right? So now, with this kind of a data, what do we actually do, right? And one of the things which you can do is to do the exploratory factor analysis, make a model, right? And then you can validate this model using either confirmatory factor analysis, or if you are trying to do some kind of a prediction, then you can do a path analysis or a structural equation model. So that will complete the entire study on a data which is collected on a Likert scale, right? So the first thing you do is to do the exploratory factor analysis, where you will be making the model, right? And what the literature says is that either when you are developing a model or confirming a model, you should have some basis for the model, right? You should have some basis for the model, right? So once you have the basis for the model, on the basis of which you have done a literature review and collected these questions, the first thing is to make the model. And that is where you do the exploratory factor analysis. And then you can validate this model, as I said, using either confirmatory factor analysis or structural equation modeling. Right? To do that, you can use another application. It could be MOS, it could be PLS, or any other application which supports doing structural equation modeling. You can do it even in an open source like R and Python. Now, once we have collected this data, right, we can answer a lot number of questions using exploratory factor analysis. First is to make the find if my sample size is adequate. Third is how well is your objective explained using the 23 variables or questions which we have considered. Is there a possibility of adding more questions, right? And which of these questions are more important compared to the objective, and which questions are less important. All these questions can be answered if you go through the entire statistics which you get from this analysis. This part is what constitutes the pilot study when you write your research paper, right? That is what comes under the pilot study, right? And then once all this is validated, you can continue your analytics or continue your analysis in the remaining portion of your in your chapters. So how do we do it? I'll show you, right? And then any questions you have, right? You are open to ask. I'll try to answer the questions. So I have created this variable view, and if you can see, I have stuck to the variable view which we discussed yesterday. Yeah, my data type is numeric, my width is 1. Since it's a discrete variable, Likert scale is a discrete variable, my decimal is 0, and the values I have described in the value column from strongly agree to strongly disagree, right? My missing value code is 9, so that if some questions are not answered, I have put a 9 over there, and my measurement is ordinal. Likert scale is always ordinal, right? So this way I have completed the entire variable view, right? So that whatever analysis is done on the complete variable view. Now, once this variable view is ready, this is the data view which I have had, and you can see all the questions are answered from 1 to 5, and if there is a missing value, then there is a 9 in that particular cell, right? Indicating that we have not been able to collect the data for that particular variable, right? I'll give you the chance to ask. Let me complete a little bit, right? So now with this data set ready, with this variable view ready, let us start doing the exploratory factor analysis, which I think is one of the major things as far as your domain is concerned. That is why I thought to pick up this kind of a data set and let you know what best is possible or what is basically done on this kind of a data set, right? So I go to analyze, right? I go to dimension reduction and I took factor, right? This is what is known as factor analysis, right? So I go to factor, right? And this is the dialog box I get. On the left hand side, it shows me all the 23 variables. So I select all the 23 variables. This is the way I select all the 23 variables and transfer it on the right side, right? If there are certain demographic variables in your study, you don't include demographic variables as far as factor analysis is concerned. Please don't take demographic variables because they are basically demographic variables are basically used for testing of hypothesis, and they are not a constituent of the factor analysis, right? Because I have seen many papers where people have included demographic variables also, but actually they don't come as far as factor analysis is concerned. Then as I said, we can answer many things using this analysis, right? And that is what I'll try to tell what all you can answer using this particular analysis. Now, you go to descriptives, right? I'll select a few things. One is the coefficient of the correlation matrix, one is the value of the determinant, and one is the value of the KMO. These are all very important statistics which tell something about the data which you have collected. It tells you something about the data which you have collected. And if you report all these statistics in your research paper, that will add quality to your work. That will add quality to your work. So I say continue. Then I go to extraction. Right now, there are two ways to do this, two popular ways to do it. One is what you call it as the principal component analysis, and the second one is known as the principal axis factoring. These are the two basic algorithms for doing the exploratory factor analysis, right? So let me start with the principal component analysis, right? And I take the method as the principal component analysis. If you read the literature, you can see the difference between all these methods also, right? If somebody is interested to go a little more deep into it, then you can also study what is the difference in these methods. Out of these methods which are shown, the two which are more important now are the principal component analysis and the principal axis factoring, right? So I'll take the more relevant method, which is the principal component analysis, right? And then I say continue. And let me see okay as of now, and then I'll come to the remaining things a little later on. So I say okay. Now this is the analysis which SPSS has done for me. All these analysis can be pasted in your Word document. Now, what are the things you can answer using this? And then I'll see how do I answer all these questions, right? So let me write down what all can you answer using the factor analysis, right? And all these answers should come as a part of your research paper. The first output which you get is what you call it as the correlation matrix, right? So let me first write down what all you can answer using this, right? First is uh, to develop a model, to develop a model, develop a model which has a theoretical background, which has a theoretical background. That is the first thing you can do, to develop a model which has a theoretical background, right? So that is the first thing you can do as far as the analysis is concerned. The second thing you can find out is to what extent the variables are correlated. I don't know how many of you appreciate this, but then to what extent the variables are correlated, right? Is the sample size sufficient for study? Is the sample size sufficient for study, right? Is there is multicollinearity is multicollinearity present in the data? Then how many factors how many factors do we get? How many factors do we get? Which variables are related to which factor? Which factor which is required to develop the model? Which is required to develop the model or scale? To develop the model, or scale, right? And then how to use these factors for prediction using linear regression, right? And then validate the model using CFA or SC. So all these things can be done as far as this analysis is concerned, and we have an answer to all these questions from the output which we get from the exploratory factor analysis. This constitutes the pilot study. This constitutes the pilot study of your research paper, of your research paper. Right. So let us see now what is the kind of output do you get. Now once you do this, this is the output which you get. The first matrix which you get is the correlation matrix, right? Now this is the correlation between any two variables. So the correlation between statistics makes me cry, and the second variable is, right, my friends will think I'm stupid for not being able to cope with SPSS, right? So this is the correlation between question number 1 and 2. This is between 1 and 3, 1 and 4, 1 and 5, 1 and 6, 1 and 7, and so on, right? This correlation matrix is very important because it tells you what is the extent of correlation between the variables which you have taken in your study, right? These correlations should not be either very low or very high. The problem is, if they are very low, they will not join hands to predict the dependent variable. And if the correlations are very high, then they will cause a new issue, which is what we call it as the multicollinearity, right? And multicollinearity is a very, very big issue in statistics. The more is the multicollinearity, the weaker is your model. The weaker is your scale, the weaker is your model. So if you can see these values, right, all these values should not be either very low correlation, all these values should not be very highly correlated. The extent to which they are highly uh, correlated, giving rise to multicollinearity, is reflected in this value of determinant as a whole, right? Smaller is the determinant, higher is the multicollinearity, right? And if uh, higher is the multicollinearity, that means your model have variables which are highly related to each other. So you'll have to do something before you can move ahead of this, because if you continue with these variables, this will not give you a model which could be validated, or the validation of this model will fail, So the first idea you get to know whether the selection of your variables is correct or not, because this is the first time you are doing this exercise, and the variables you have got to know from the literature review or from a established scale, right, which has been already developed. But you are doing it for a different population, for a different sample altogether. So you could have results which are different from what the other study has been doing, right? So you should look in this correlation matrix that the variable should not be highly correlated and the variable should not be very loosely correlated. Higher correlation is reflected through multicollinearity, which is reflected through this value of determinant. I don't want a very small determinant. How small? That depends upon the number of variables, right? So suppose like I have 23 variables, right? So what my experience says is, this is not documented anywhere, but then if I have 23 variables, then I shouldn't get a determinant which is less than 0.0001. If I get a determinant which is less than 0.0001, then my variables, there is a good enough correlation between my variables, which will be reflected in the value of the correlations shown in the matrix. So in that case, you will have to relook at your variables before you do anything else, right? And if you continue beyond this point, then whatever model you will make out of EFA, that model will not get validated when you do CFA. So that is the first part of the story, which itself is very, very important, because we don't actually know, right, to what extent these variables are correlated as far as your sample is concerned. The second is the next table which you get in factor analysis gives you something even more important. Is the first is the value of the KMO, which you get as 0.930 in my case, right? But this value gives you an idea how accurate is your sample size, because sample size will play a very important role when tomorrow you do some testing of hypothesis and you will go in for normality, right? So it is better to make sure that I have an adequate sample size for the number of variables which we have considered in the study. This value of KMO as a benchmark should not be less than 0.7. If the value is less than 0.7, then the variables may be correct, but you need to increase your sample size so that you have sufficient sample size to handle the number of variables which you have taken in the study. The third, if you can see, is something which is a very important test, like we were discussing the Shapiro's test yesterday. There is something known as the Bartlett's test. This test is very important. And if you can see in the last row, it gives you the value of the significance, which is 0 in our case. So the significant value should be less than the level of significance. That means your variables are giving rise to some factors which are significant, If this value of significance is more than 0.05, right, then again there is a reason to relook at your variables. Your variables are not giving rise to factors which are significant to make the model. So that is what you can see in the test of the Bartlett's test of sphericity and the significant value associated with that test. These are the primary things which you should see once you do your EFA. My data set is very clean data set and I'm getting values which are all very good. But this will actually not happen when you collect the data in real life. Either you will get too much multicollinearity, or your sample size is less, or your factors are not significant. All these issues will come up because that is what is actually research. These issues will crop up when you are doing a real life research. The next thing we would like to answer is how many factors can be obtained from these 23 variables, right? So how many factors do we obtain from these 23 variables? To find this, right, how we use something which is known as a scree plot. It's a very popular plot. This is known as a scree plot. This is known as a scree plot. Now let us see how do we get this scree plot. I'll again go to this factor analysis and I'll take one more thing as scree plot. I'll take this option of a scree plot now, right? And I'll show you how to interpret this scree plot to let you know, right? Now this is the scree plot which you get in the output. This is the correlation matrix. This is the KMO test, right? And let us see the scree plot which I get from the analysis. The scree plot which will help me to get the number of. Now this is the scree plot which you get, right? Now this scree plot is between two axes. One is the eigenvalue and one is the number of factors which you get, right? So for the number of factors, the eigenvalue should be greater than 1. So if you see from here, if you draw a horizontal line from 1 and then count the number of circles. So you have 1, 2, 3, 4 and 5. Roughly, you should get 5 factors, right? So you can take a printout and draw a horizontal line from 1, right? From an eigenvalue of 1, which will be somewhere in between 0 and 2. You can draw an horizontal line and drop it on the plot, and you can count the number of circles before it intersects your plot. And hopefully, as I can see, I can get factors which are either 4 in number or 5 in number, right? So this scree plot tells you the number of factors which could be anything between 4 to 5. Between 4 to 5 or 4 to 6. Anything between 4 to 6, right? Which we will also validate, right, from the eigenvalue table. So you should put this scree plot, which will help you to identify. How many factors do you get. Now let us move to this eigenvalue table, which again will tell you how many factors are you actually getting. So if you can see on the right side, how many rows you get? 1, 2, 3, 4. And below this value, this eigenvalue comes out to be less than 1. So these 23 variables, when you make the model, will be reduced under how many factors? It will be reduced under 4 factors. Right? Later on, I'll show you how to develop the model also in MOS. Right? So you get how many? You get 4 factors from the 23 variables. Right? And the last column shows you how much of the variance is explained in the dependent variable from these 4 factors, which is roughly how much? 50.3%. 50.3%. That means the model is good to an extent of only 50.3%. That means what? This value needs to be increased. if you can make this value reach somewhere close to 70%, which is generally what the good research papers require, that the total cumulative variance should be somewhere around 70%, should be somewhere around 70%. Then you have a good model in hand, which could be validated. As of now, I'm getting the cumulative variance explained somewhere around 50%, right? So I'll try to improve my model. This is what actually research is, right? To begin with, I'm getting a cumulative variance explained as 50%, which I would like to increase it to somewhere around 70%, because that is one of the requirements of a good research paper. So I've answered the adequacy of the sample size. I've answered whether my factors are significant or not. I've answered to what extent multi-collinearity is present in the data. From this tree plot, I have answered that the number of factors I can get is 4, and these 4 factors are explaining how much? They are explaining 50% variability, right? And the benchmark is generally that our model should explain 70% variability. 70% variability, then it is considered to be a good model. I'm just sharing with all of you, because once you do this analysis, you must have an idea how much these values should be, so that your paper looks good. Your paper looks good. So if you want your paper to look good, your cumulative variance explained should be close anything to 65 to 70%. Right. Now, to develop the model, I need one more information, which is how these variables are loading onto each factor. Then only I'll be able to make the model and then validate it using either CFA or SEM. Now, to do this, I need to go to this component matrix. This is what is the component matrix, and you can see there are 4 columns for the 4 factors which I have actually extracted. For the 4 factors which I have already extracted, right? So you can see that for variable number 1, this is the loading. How much of this variable is loading onto each of the factors, right? We will look for the highest value, right? So the highest value is 0.585. That means question number 1 is loading on question number 1 is loading on factor 1. Similarly, if I see for question number 2, the maximum value is 0.548. That means this question is loading on factor 2. This question is loading on factor 2. Similarly, if I see the question number 3, the maximum value is 0.629. Again, it is loading on factor 1. So similarly, we can find out, right, which variables are loading onto which factor. This information will be required when you finally make the model for validation, right? When you finally make the model for validation, how is the loading of each variable onto each factor, right? That is what can be shown using the component matrix. Now, once I get this information, I'll be able to make the model. There's one more answer which you get is the value of the communality. This is the value of the communality for each variable. Through this, you can get to know, right, which variable is more important in reflection to your objective, right? So you can pay more emphasis to it. If this is a variable which is more important as far as your personality scale is concerned, then to make the personality of an individual better, your concentration will be more on that variable. That concentration will be more on that particular
Sir,
variable.
could I ask a question to you?
Yeah, I'll just give you time. Let me, sir, complete it. Otherwise, I'll not be able to complete it, the whole topic, right? So this communality value is also very important, and it gives you a reflection of how a particular variable is more or less important. Just when you do a prediction of something, I'm trying to make a model to predict, suppose, the personality. I should know which variable is more important in having an impact on the personality, so that I am able to pay more attention to that variable compared to the other variables. And this is the question which you can answer using the communalities which you get from the the output of the factor analysis. So this table you can study and you can find out. I think the most important is 0.7 to 9, right? And as far as SPSS usage is concerned, I have never been good at mathematics. That means even if you are not good in mathematics, right? You like proficiency in mathematics is not a prerequisite to use SPSS. That is what it is trying to say, right? So I'm trying to convince all those people who don't have a background of mathematics, they can also use SPSS, because that is the way the question has been designed, and the maximum communality is for that variable. Trying to tell us that a prerequisite of mathematics is absolutely not required if you intend to use SPSS for analyzing your data in the research work, followed by the other variables, So it gives you a very clear picture that when you are developing a scale, which variables are more important and which variables are less important. Right now, after you do all this, you can now prepare a model. If all these statistics are in place, but I have taken a very clean data set. Most of the things are coming in place, but this will not actually happen when you do your analysis for the first time on the data collected in the field. Either your KMO value will be less, or your factors will be insignificant, or you will have too much multicollinearity, or the amount of variance explained will be 35, 40, 45%, right? In all these cases, you'll have to do something to make these values better before you make the model and validate the model. That is what I'm trying to say, right? Don't think all these values will come very good when you do your analysis for the first time. If that is the scenario, then the whole concept of research will get defeated. Research means you are trying to explore something for the first time. And when you are trying to explore something for the first time, naturally bottlenecks, right, hurdles, right, will always come. And that is what you need to rethink. What should I do to make my statistics look better, right? And my model gets validated. Now let me show you, once you get how your statistics is good for all the different requirements, and you know which variable is loading onto which factor, right? Now I'll make a model. I'll show you, right? I'll show you how to make the model and validate it using what I call it as the SPSS MOS, right? This particular application is used for creating a model and then to validate the model So I have taken the input from the exploratory factor analysis, which I have done in SPSS statistics, and then I'll make the model in SPSS MOS and then validate the model So I'll show you different kinds of models which you can validate in MOS. Right. So there are basically 3 different kinds of models which you can make. Right. So once the model is created using EFA, right? You validate the model. The only thing is, all the output which you get in EFA should be in place. Right. Now, to validate the model, there are 3 basic things which you do, or there are basically 3 kinds of models which you prepare. One is what is known as path analysis. The second is what we call it as the CFA, or the confirmatory factor analysis. And the third one is what you call it as the SEM, or structural equation model. I'll show you the model for all the 3 so that you know which one you can do as a part of your research work. So SEM, or structural equation modeling. Right. And to do this, you can use tools like MOS AMOS basically stands for analysis of movements of structures. For all those people who want to have that idea, then you can use PLS, then you can use Literal, and you can use the open source R and Python, right? R and so these are the tools you can use. I am using the tool AMOS. I am using the tool AMOS, right? As far as the license tool is concerned, AMOS is the best. And as far as the open source is concerned, you can use both R and Python. Not very difficult, right? Now, let me show you the three kinds of models which you can make and validate from the output which you have got from EFA. Now, the requirement is what? That you should know from EFA, you should know which variable is loading on which factor, which you can get to know from the component matrix, from the component matrix. Now let me show you the model for all the three cases. How does the model actually look like, right? One is what we call it as the path analysis. The second is what we call it as the confirmatory factor analysis. And then what we call it as the structural equation modeling, right? And then after this, you can also study, right, the mediating and moderating effect of an external variable on the model. Right. Suppose you are trying to develop a model for, suppose, just giving an example, for the sales of Pepsi, then you can study the effect of an external variable like the competition in the market. Does the competition in the market affect your sales or not? Right. That is what is known as, there are two kinds of effects, the mediating effect and the moderating effect. I'll go into all this a little later when I tell you what is the difference between the mediating effect and a moderating effect. So let me show you, right, how do you make the model and how do you say, how does the model actually looks like. So I go to AMOS, right, I'll show you three models first, right. Now the first model is, this is the first model, right, where I'm trying to predict, I'm just taking it as an example, right, I'm trying to predict the performance based on knowledge, value, and satisfaction, right. So I have only four variables in my study, right, I have only four variables in my study: performance, knowledge, value, and satisfaction. I'm trying to measure the performance based on knowledge, value, and satisfaction. The diagram which you see on my screen, right, it doesn't have any factors. It has only the measured variables, and there are four measured variables: knowledge, value, and satisfaction, measuring the performance, right. This is the way the model looks like, and this is an example of what we call it as the path analysis, right. So this, once you run this model, you can find out how well you can predict the performance based on knowledge, value, and satisfaction, right. So this is a diagram which is what we call it technically as a path analysis, because you have only measured variables. You have only measured variables and you don't have any latent variables or factors coming into picture. So it is absolutely not necessary that you should get factors in order to validate the model. If you feel that your measured variables are good enough, right, then this is the kind of diagram which you will make, or this is the kind of model which you will make, and then you will validate that particular model. But what happens actually in real life is that the model which you see on my screen may not give you very good results, and that is where I'll show you a different, altogether a different model. This is what we do. Now, the same variables I have: knowledge, value, performance, and satisfaction, right? And satisfaction measuring the performance. But what I have done is, instead of just measuring it through 4 variables, how many variables have I taken? 1, 2, 3, 4, 5, 6, 7, 8. In my case, I have taken 23 variables. Right. Now, this is what you call it as the structural equation model. The structural equation model, where I'm predicting performance, which is a latent variable or a factor, through 3 latent variables: knowledge, value, and satisfaction, which are itself measured through the measured variables: knowledge 1, knowledge 2. These are just names of the variables. Value 1, value 2, satisfaction 1, and satisfaction 2. This is an example of a structural equation modeling, and this model or this kind of modeling will give you a better model or a better model to predict the performance or the personality of an individual, right, compared to the model which we made as a path analysis. Now, this has basically 2 components, right? So this is what is a path analysis, same variables, but your model is what technically known as a path analysis. The same variables, but measured in a different way. This is what you call it as the structural equation model. Now, in between structural equation model and path analysis is somewhat which we call it as the CFA, or the confirmatory factor analysis. Let me show you a figure which is only confirmatory factor analysis. Let me see if I've got it. I just wanted to make you see that particular. Right. This is what is confirmatory factor analysis. Right. So if I go to the same diagram again, if you remove this portion, this whole portion, right, then this is known as confirmatory factor analysis. So this structural equation model has basically 2 parts. One is what is on the left-hand side. This is on the left-hand side, which is known as the measurement model, right? And on the right-hand side, this is known as the structural model, right? So confirmatory factor analysis, I'll just write it down. Path analysis has only measured variables, CFA has only the measurement model. That means you are not trying to predict anything, you are just trying to validate the model, right? Used only to validate the model. Then the third one, which is the most complex, is this one. This is a combination of measurement model and structural model, and used to validate a model and to predict a dependent variable from the model. So that depends upon your requirement. If you are interested only to validate the model, best is to go for CFA. If you are interested to validate the model and do some kind of a prediction, then if it is based only on the measured variables, go for path analysis. If it is based on the latent variables or factors, you go in for the most complex one, which is what we call it as the structural equation model. But the most difficult part is to make this model. The model which you see on my screen is created. This is what I have created manually on this canvas. I have made the complete drawing. How to draw it, maybe we'll discuss sometimes else. But this is what not the software has made for me. This is what I have made and told the software that this is a factor, right, on which these two variables are loading. This is what I have made it, right, on this MOS. So this is what you also need to make it graphically. The beauty of making it graphically is that you can remove these arrows whenever you want, right? And you can modify the model on the go itself, dynamic, right? You can make the model look dynamic. You can keep on removing some arrows and adding some more arrows and then validating the model. That is the beauty which you can do over here, right? But the model has to be created by the research scholar. That is what I'm trying to say again and again, right? How do you draw this model? For that we have lot many tools available on the left hand side. But all those people who are seeing it for the first time, they may get an impression that this model is automatically created by the software. No, it doesn't create the model. The role of the software is to validate the model using some statistical values. This model has to be made by the research scholar. This model has to be drawn by the research scholar, right? And how do you draw it? You first need to do EFA and get an idea which variables are loading onto which factor. Like I know these two variables, knowledge 1 and knowledge 2, are loading on knowledge. The variables value 1 and value 2 are loading on value, and the variables satisfaction 1 and satisfaction 2 are loading on satisfaction. So similarly, you can draw a model for the case which we have done, right? So you have this output. From this output, you can find out from the component matrix which variables are loading onto which particular factor. So let me show you, right? Suppose I say question number 1, 3, and 5 are loading on factor 1. Now, how do I show it? I'll just open a new black. This is the blank canvas, right? And I'll just show you. Suppose they are loading on the first. This is 1. This is factor number 1, right? Now I just click on this, right? And how many questions are loading? 1, 2, 3. This is question number 1. This is question number 3. This is question number 5. I'm just trying to tell you how am I making the model in MOS. Similarly, you'll get a second factor, right? Which is this one. Suppose on this you are loading 6 questions. So you should get 6 arrows. How do you do it? 1, 2, 3, 4, 5, 6. So this way you'll get to know, right, how many are coming on this particular. So I'm just trying to tell you this is the way the model has to be made, because many people carry this belief that the model is automatically drawn in MOS by giving some input. No, that doesn't actually happen, right? And once this model is made, like the model which I have shown you over here, this is the model I have drawn actually, right? This model is obtained from the EFA. And then I can run this in this MOS, right? And find out whether statistically my model is validated or not. For that, we have a number of statistical values which need some kind of an interpretation, right? But once you do it for the first time, the model itself may not run. It will give you a lot many errors, and we need to remove all those errors before MOS will tell you whether your model is validated or not. What I'm trying to tell is, first, making the model itself is a task. Then once you run the model, getting errors when you run it is also something which will automatically come, and we'll have to see how these errors are taken care of. That also is a task which we need to understand. Now, when you're like you write a program in C or C++, until unless you remove all the syntax errors, your program will not run. Similarly, you'll have to remove all the errors before MOS can run the model and validate it. And once the model is run, it will tell you whether the model is significant or not, using some statistical parameters like the p-value, the goodness of fit index, right, the RMSEA value. All these parameters will indicate whether your model is validated or not. So this is the way, or this is the kind of exercise you do when you collect your data on a Likert scale. Right. The impression I got yesterday was that most of you are collecting data on the Likert scale. So that is why I decided to take something which is frequently done on a data which is collected on a Likert scale, or the analysis which is generally done when you collect data on a Likert scale. Right. This kind of a data is generally used for developing a new scale. Developing a new scale means developing a model, and then you validate the model. Then you validate the model, right? You don't use a Likert scale when you are trying. Yesterday I said you don't use a Likert scale for testing of hypothesis, right? Because the reason is the test of normality is very important, right? And the data collected on a Likert scale, the chances of the data collected on the Likert scale to pass the test of normality is low. If it passes, very good. If it passes, very good. But then that assumption should be satisfied before you can do a parametric test. Before you can do a parametric test. Now I'll take up your questions so that I get sufficient time, right? So that.
Sir, could I ask you?
Yeah, sir.
Yeah. Sir, can you go to your this one, what do you call it, SPSS? Yeah, that, yeah. Can you go to that determinant?
Which one, sir?
Determinant, the first one.
This is the value of the determinant.
Yeah, see, sometimes what we are getting is we get a message, the determinant is not positive.
Yeah, sir.
So why that happens? Can you explain?
That is because there is too much overlapping between your questions.
Okay.
So you need to relook at the variables on which you have collected the question. Either it requires omitting of some variables, or it requires inclusion of some more variables, or there could be lot many missing values in a particular variable, right? All this could be happening, right, which is giving you a determinant which is not calculated.
Okay, and the second, yeah.
Unless you get a value of the determinant, right, don't move forward, sir. Because that issue, that problem is still there in the data or in the variables on which we have collected the data.
Okay, sometimes the determinant value is very high, and say for example we have
High means, sir?
High means, sometimes it is saying that it has to be below 0.1.
No, once you say it is high, what is your thought process of what you say as high?
Say for example the point is going to 9 or 10 or something like that.
No, you will never get a determinant of 9 and 10, sir.
Okay.
Never get it, sir. That high determinant you will never get, sir. Yeah. If you must see at the end, it must be written exponential minus something.
Okay.
Complete value of the determinant, but you will never get a determinant which is 9 or 10, sir.
Okay, sir. Yeah. Thank you.
The bigger problem is that most of the times we get a very small value of determinant, sir.
Okay.
That is a bigger problem, sir.
Okay.
And lower is the value of the determinant, your variables needs correction.
Okay. So what is a normal sample adequacy of value, KMO and Bartlett? What can be? Here I see 9.3.
The benchmark value, your KMO value should never be less than 0.7.
Oh, 0.7. Okay. Benchmark is 7.
Benchmark is 0.7. The moment you get less than 0.7, then the first remedy you do is to increase the sample size.
Oh, increase the sample size. Okay. Another question to you.
Sample size is not adequate as per your variables are concerned.
Yeah. There is also another called rotation matrix or something.
Rotation matrix, you generally go in when this loading on the principal component matrix is not clear.
Okay.
But in my case, I don't need to go in for rotation. See, rotation is something like, suppose you are not able to see a student in the class from where you are standing. Okay. You are able to see a student So what you
Okay.
do is you change your position, right?
Hmm.
So that the visibility of all the students is much clearer. The students are not changing their position. You as a teacher is changing your position. So that
Okay.
is where when the component matrix is not very clear, you can go in for a rotated component matrix.
Say, for example, you have made now 4 factors.
Yeah.
You will also name them, right?
I can name them depending upon what kind of variables are coming on each factor.
Okay, 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 okay.
This exercise I have done and I have named the factors also, sir. The
Ah,
first factor has all the questions which are related to the fear of statistics. The
okay.
second factors have a set of questions related to the fear of computers.
Hmm.
The third one is the fear of mathematics, and the fourth one is what I call as peer evaluation. What people think when I do this analysis in SPSS.
Okay, okay.
I have
Thank
done,
you, sir. Thank you.
I have
Sir, I
done,
have a question, sir.
yeah,
Sir, I'm a bit of a beginner in this, sir. My question may seem very elementary. Sir, just now you told us that, sir, when we are doing SCM,
yeah,
for example, knowledge is being measured by two observed variables, 1 and 2.
yeah, yeah.
So we'll assign those values there. But sir, if you're doing path analysis, there
Yeah.
we are saying that we are only using observed variables. So sir,
Yeah.
what do I do? Do I add the scores of question 1 and question 2 and that I will assign to knowledge, or how will I do it, sir?
If you are doing the path analysis, then naturally you'll have to add the data for question 1 and question 2. That is the only issue you have, or that is what best you can do.
Okay, sir. So let's say 5 questions are addressing, are observed variables for knowledge. I will add the scores, and that additive score which I have, I will use for knowledge, sir.
Correct, correct.
So second question, sir, is
Because
the
that is
path.
best if you want to do only path analysis.
Right, sir. And sir, second question is in path analysis, sir, supposing I get the path coefficient between knowledge and performance as, let's say, 0.7. So
Right.
do I interpret it the same way as we interpret regression, saying that 1 unit change
Yeah.
in knowledge will result in 0.7 unit change in performance?
Absolutely. These are the regression coefficients, and these regression coefficients are exactly the same which you get in linear regression in SPSS. Linear regression in SPSS is the same as path analysis in this AMOS.
And sir, the same interpretation will apply for the structural model coefficients in SEM, sir?
Right, absolutely. That interpretation will not change. Whatever figure you will get, I'll just show you. Whatever I have run this model actually, I'll just show you. This is I'll show you over here. Now this is, if you run this model, this is the way you run this model, right? And then you get these coefficients. Can you see these coefficients? These coefficients are same as the regression coefficients. That means 1 unit change in knowledge will change 0.25 unit change in performance. 1 unit change in value will give you around 0.15 unit change in performance. So these are the regression coefficients. This remains the same whether it's a path analysis or it is a structural equation model.
Right, sir. So one more question, if I can ask. In this model, sir, we are not showing indirect effects, but just I wanted to know, sir,
Yeah.
that the path coefficients are the same values, which are there for the direct effect.
Now you can make a more complicated model. Here you are just showing the direct effect of performance of by 3. What you can do is you can also put one more over here, right?
Right, sir.
And then that will be an indirect effect of performance through sales, right?
Right, sir.
And then you can find out also, you read, there is something known as a Sobel's test. That Sobel's test will tell you, right, whether that variable is, first you can find out how much is the direct effect and how much is the indirect effect. That answer you can get. And also you can find out that whether that indirect effect is significant or not using a very popular test you can read. That is what is known as the Sobel's test.
Right, sir. Thank you so much, sir.
So anything, this is what actually you do when you collect your data on a Likert scale. I am just trying to tell you what you should do if your data is collected on a Likert scale. And the impression I got was that most of you are collecting data on a Likert scale. And that is why I took up this whole exercise, trying to tell you what best you can achieve if you have collected data on a Likert scale. Otherwise, there are so many things which you can do, right? But you cannot do all those stuff if you have a data which is collected on a Likert scale. For that, your data must be on a ratio scale, or it may be on a nominal scale, right? But this is what is possible, and this is what is statistically done if you are really doing it on a Likert scale. Now, many more questions crop up actually. See here, I have a rosy data set where all the variables are measured on the same scale of 1 to 5. But this may not happen. Some questions are measured on a 1 to 5 scale, some are measured on 1 to 3 scale, and so on. Then how do we do it? That is again, because it is absolutely not necessary that all the variables in my questionnaire are measured on the same scale. Absolutely not necessary, right? So then what do we do, right? If all the questions are measured on a different scale, or there are at least 2 or 3 scales in my whole questionnaire. One set of questions from 1 to 5, second set of questions on 1 to 3, and third set of questions on 1 to 7. Then how should we do the same thing? Again, we will have to think, because that is a more practical scenario compared to a scenario where all the variables are measured on the same scale, as in my case. So that is the way the complications keep on increasing, right? This is the first complication you have, and similarly, there are many complications which happen when you develop the model, right? And as I told you, when you make this model in MOS and validate it, right now things must be looking very easy to you. But when you do it, I'm just trying to warn you that it will take a lot of time, first in making the model, second in validating the model. You'll get so many errors due to all different reasons, right? And then maybe once all the errors are removed, you are not getting the correct answer. We have written a program in C, all the errors we have removed, but the answer is still not coming out to be correct. That means your model is, even if the validation is done, the model is not coming out to be significant. That scenario is the most common one, right? Or you are getting a very big value of RMSEA, your goodness of fit is very low. All this indicates that you need to rework on your model, even though it is validated, even though it is validated. Anything else? Any
Sir, shall we end the session?
Okay. So any doubts you have, you can.
Sir,
Yeah. Yeah, ma'am.
so shall we end the session?
Yeah, that is what I'm saying. If there are no
Yeah,
questions,
thank
yeah. If you have any problems, any
uh,
issues
th
that, you can always write a mail. That is what I can say.
Okay, sir. Thank you, sir. I would like to express our deep gratitude to you for accepting accepting the invitation and sparing your valuable time. Sir, the session were very interactive and remarkable. Thank you so much, sir. Now the next session is at 12:30 p.m. I request all the participants to join the session 10 minutes before the scheduled time.
Thank you.
Thank you, Saurabh, sir.
Thank you.